solution where you have an alkene, okay, at least one double bond somewhere within the structure, could be a ring, could be in a chain, etc. If it is in a basic solution, and how are you going to know it's basic? Yeah, it says that it's in a basic solution or has sodium hydroxide. The potassium permanganate, and it's only with the potassium permanganate in a basic or an acidic solution that these reactions are taking place. The double bond in a basic solution is changed into a single bond. Now, we're not doing arrow push with this, okay? There's a mechanism that's going on that we don't need to worry about. And you don't need to worry about the shape of the permanganate ion or polyatomic ion, but it's got a manganese in the middle and then it has 4 oxygens going around it. And so what happens is that we have this breaking or the changing, the metamorphosis of the double bond to the single bond, and then that potassium permanganate polyatomic ion hovers above it and drops an oxygen down onto the substance. And now we have a hydroxide as well, because again, there's some hydrogens that are attached there. But this is actually the easier of the two, the basic one, where you break the bond and wherever the bond's broken, pop 2 hydroxides on there. That's the easy one. Where the fun comes in is in an acidic solution. What's that? What's the 37%? That just means that 37% of that will form, and then nothing else will happen.
Do we have to know how to
No, you don't. No, don't worry about that. I just put that on there. I copied that from somewhere. All right. So now what we're talking about is we still have the permanganate, and it's in an acidic solution. And in an acidic solution, what's actually happening is the double bond is getting cleaved. In other words, we're now talking about cleavage. So we're going to break that double bond. And what's going to happen is you're going to have 2 halves or 2 sides of the double bond. Okay. And I don't want you to get into the nuances of like, how in the world do those 2 carbons have those 2 bonds? Well, they don't, because they're actually going to do something. So there's a couple scenarios where if we look, and I've got a bunch of examples that I'm going to show here. But if we have, say, the carbon and the rest of the carbons are not hydrogen, so that's why I have the R there. Maybe this is a methyl group here, and that's a methyl group, or the chain, so it keeps on going. So it's a carbon with something, okay? If you see it looking like that and it's not a hydrogen, then what we're going to do is we're going to add an oxygen and make a ketone. Okay, so a ketone will be branched on that carbon that got cleaved. Okay, so again, we're referring to same thing's going to happen on both of these. Okay, so that's the scenario. Okay, that's the first one. That's the easy one. The second one, we have the rest of it is carbons, and then we have a hydrogen branched off. What's going to happen is we're going to put an oxygen where that double bond is at, and then we're going to insert another oxygen here. So when you do that, now we've got the carbon with the rest of the molecule. We have an oxygen, and we have a hydrogen, and we have a doubly bonded oxygen. What is this referred to in your functional groups? Carboxyl group or carboxylic acid. Okay, so that happens when we have one hydrogen on the carbon, and then the rest of it is the carbon. So you're always going to have carbon is going to be joined to somebody and a double bond. Okay, the last scenario, okay, is that we're going to have the carbon doubly bonded, gets cleaved. We're going to drop, let's not do that. We're going to drop an oxygen here, and we're going to put it there. So now what we've got is, let me redraw this. So we've got carbon with a doubly bonded oxygen. We have OH. So it kind of looks like we have 2 alcohols, but something weird happens. So that originally forms, but really what is happening in the solution, there's some more steps where carbon dioxide is formed and a water molecule is formed. So we'll go one additional step. So when you see this, this is actually making a water molecule, which we don't worry about because it's already in an aqueous solution. But the thing that we do care about is the carbon dioxide. Okay, so you'll have a carbon dioxide molecule. So there are 3 scenarios. So the first one, where it's carbon, carbon, we're going to make a ketone.
Is that how you spell it?
Ketone?
Yeah.
I think
Is it
so.
Y?
I thought it was KE.
Okay, could be, yeah. Okay, and then, yeah, it is actually. Goodbye. And then in this one, we form a carboxylic acid, and here we form a carbon dioxide. So let's look at our first example. Okay, so we will break, we'll break the double bond. And so this will turn into a chain. And all these examples that I'm going to show you now are in an acidic solution. And one thing that you may want to do, it helped me as I was making this up last night, is draw the hydrogen on there. Okay. So draw the hydrogen on there. And then what I also did was I labeled that's number 1 carbon, 2, 3, 4, 5, and 6. So that when I draw out my shape, I'm going to go 1, 2, 3, 4, 5, 6. Okay. And then what I have here is I have the hydrogen is on that end, and I have a hydrogen on that end. That's me breaking it. Now, I wouldn't write that just yet, because what are we going to do? What scenario does this fall under? Does it fall under, and I'll ask you, is it the first scenario, the second scenario, or the third? The third? Second. Because what we have here is, let me color in the carbons. So you have a carbon here, and then we have that hydrogen. So when looking at it, you got a carbon, carbon, and then the hydrogen. So that's why I did those 3 at the beginning, because those are our 3 different scenarios. So knowing that you have the 2 carbons and then the 1 hydrogen, so we can say that this hydrogen is going to change into a, again, we're going to add an oxygen here in between the oxygen and the hydrogen, and we always add it to here. So this changes into an alcohol, but we also include that. So we've really added a what? Carboxyl group there. Will the same thing happen on the other carbon?
No.
Okay, so let's draw it. So we got a carbon, carbon, and a hydrogen. Yeah, it'll be exactly the same on both sides. Okay, so we'll have a OH and a double bond. Okay.
When you numbered it,
Yeah, why
didn't
didn't
you number it differently?
Here,
because of the
1, 2, 3, 4, 5, and 6. What I'm doing is I'm numbering like the carbon. I'm not numbering as we're going to name it.
Oh, okay.
Oh yeah, I'm not going 1, 2. Sorry, because I wanted you, when we have that ring, we're going to open up the ring and turn it
So
into
split
a chain.
number
You
it
always
at
cleave it
the
at the double bond.
Okay, that
Yep.
makes sense.
All right, so let's look at another example. Okay, so the cleavage will take place right there. Okay, so now we've got 1, 2, 3, 4, 5, 6, 7, 8 carbons. So 1, 2, I'll number it like that. Again, not for nomenclature purposes. Okay, so when looking, and actually let's draw this out. So 1, 2, 3, 4, 5, 6. And then I'm going to have a methyl group here. I'm going to have a methyl group here. Okay, I'm just, again, oversimplifying. So when I look at this, do I have any hydrogens here before I cleave it? No, not on the number 2 or number 7 carbon is what I meant to say. So we're looking at which scenario? The first one, second one, or the third? First, because now we have a carbon with a carbon. So that's a carbon and that's a carbon. Of course, that's a carbon. So really, the only thing that we're doing is putting ketones on there. Okay.
What type of question, like, will it ask you to leave it? Or like,
No, it'll, if you see a reaction where you have the potassium permanganate in an acidic solution, it's going to expect you to say to cleave it and do what we're doing here. Yeah. All right. Here's another one. Okay. So as we stand right now, this is a carbon and this is a carbon. Those are the two that you really want to focus on. Okay. So where is the double bond going to get cleaved? Right here. So does the ring turn into a chain?
No.
No. Okay, good. So we're going to have our, as pretty as you can make a hexagon. And then, so there's the carbon of focus. So if we look at it, we have a carbon here and a carbon here. So what's going to go there? What's going to go on that carbon? Yeah, a ketone. Okay. So we've got a ketone, and now we have this carbon all by itself. So really, if we look at it, and again, probably not a bad idea to draw it because carbon always has to have 4 bonds. So if you don't see it, then it has to be hydrogens. So now we have which scenario? The first, second, or the third. So again, we're going to go through that process where we form this, and we're going to make water and carbon dioxide. But to simplify this, we just say we have, or if you want to draw it out, you can go like this. So we have carbon dioxide. Or you can write CO2. I've seen CO2 written often. Okay.
You said it's good to just write CO2.
You can, yeah. Correct. But that option's open. All right, so now we're going to look at some chains. I think I may have some more rings as well. Okay. So again, the cleavage takes place there. So when we look at it, we've got carbon. So we've got this structure, which I'll draw out first. Okay. And this is the carbon with the action. So what else do we have on this carbon? There we go. That's where I want you to start thinking. So we've got a hydrogen on there. So if we have a hydrogen, actually, then that means we're going to have that. And what else should we put on that carbon? A double bonded oxygen. Okay, so we've got a carboxyl group on that. Then on the other side, we have that. And so right now, is there anything else on this carbon? Is there anything else? No, because we had the double bond, we had the 2 methyl groups. So what should we have on this? Ketone. Good. Makes sense? Starting to get to make sense? Okay. All right. Here's another scenario. Cleave it here. So the 2 carbons of interest here and here. So then we've got boom, 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 boom. And then the other one, oh, sorry, that goes on. And then, so what will we have on this carbon? Ketone. Good. There you go. Now you're getting it. So ketone there. And what else are we going to form since we have that with a hydrogen? Good. Now, just remember that we are making water and carbon dioxide. It's actually making carbonic acid, but in that solution, it breaks apart into carbon dioxide and water. And also another fun fact, if you leave pure water out or just regular water out and expose it to the atmosphere, you will make carbonic acid as well. Split it here. So we've got our carbons of interest on that one. Looks like this. So what do we have? Ketone. And then we have another ketone. So those look alike. Here. So carbons of interest. Ketone on that one. There you go. So then this carbon actually has a hydrogen attached. So we have a carboxyl group. So we have that. And then I'll use this OH. And remember that we're always going to put a doubly bonded oxygen on one of those carbons. And then what the other thing does depends. All right, so now we've got the ring again. And so I'm going to split it here. What I want you to remember is that we technically have a hydrogen on each of those. So when we unfold this, carbon, carbon, carbon. So on our number 5 carbon, we've got another one there. So 1, 2, 3, 4, 5, 6. That methyl group is there. So what is happening at this carbon? So on this side. There we go. Now we're getting it. Carboxyl. So I'll zoom in. So we're going to have doubly bonded oxygen and then the carboxyl group. And then on this one here, same thing. Good. So doubly bonded. And I don't care which way your things are going. Okay. Just make sure your methyl's in the correct spot. Okay. And I think this is our last one. So cleave that. Carbons, all 6 of these. So 2, 3, 4, 5, 6. I'm going to put a methyl here and a methyl there. So at this one, we have that. So what goes on carbon number 1? What is it? Ketone. Good. So just a ketone. And then on the other side, carboxyl. Excellent. Yeah, go ahead.
Why would the methyl group not be on?
That's what I did.
Oh, it is. My bad. Sorry. Thank you.
Then would it still be a ketone?
It would still be a ketone. Yep. Yep. Good catch.
Can you go up?
Wait,
Because when we look at it, our scenario is this is our here. This is our carbon of interest. So R and R.
Go up.
Yeah. Try in. Which one do you want to see again?
Number 4. That one. Yeah, you're there.
There.
Yeah.
All right. So on the homework, I have you doing a couple of these and then going in the opposite direction. Okay. You good?
Yeah.
The last one? Okay.
This is the one.
wait, so on the last carbon, it's
So this carbon right here
yeah,
is right here.
yeah, but what, yeah.
So we have that, and also what's not shown is the hydrogen. Yeah. So I would recommend showing the hydrogen because then you squeeze an oxygen in between them and then pop a double bond. Yeah.
Me neither.
I got it.